I'll go ahead and get started then. Well, thank you very much for having me as part of the giant Synapse Data Toboggan event. Really appreciate that, like the cool running version of this. My name is Ginger Grants, and I'm going to be talking about, surprise, surprise, I'm going to be talking about Synapse, but I'm going to be talking about Azure Machine Learning, as well as machine learning within Synapse, so a way of combining both of those. So as you can tell from the accent, yes, I am from America, and I live in Arizona, which explains the cactus. I am a Microsoft Data Platform MVP and a certified trainer, and I do all sorts of things data. And if you want to know more, either check out my blog or check me out on Twitter. I'm on there way too much. All right, so with Synapse, there's a whole bunch of different features that you can use and people have talked about. As a matter of fact, I noticed that in some of the documentation for Azure Data Studio, they're still calling it Azure Data Warehouse instead of Synapse Dedicated Pool. So, but I understand why people do that. Also integration, as well as Spark notebooks and the integrated applications, Power BI, Azure ML, Cosmos DB, Azure DevOps, and GitHub. But I'm going to be focusing on Azure ML and Spark within Synapse. And I'm looking forward to sometime when we can integrate SQL DB with that. That's just a shout out to somebody who might know the answer to that question. All right, so the Synapse architecture basically is on top of data lake storage. So looking at how you're going to incorporate all of your different data on top of Synapse. And I primarily put up this diagram because I can't say Azure Data Lake Gen 2 without tripping over myself at some point in time. So I'm just going to call it ADLS so you know what I'm talking about. So we've got the different ways that we can do ML, either with Apache Spark, cognitive services, and model training with AutoML. And I'm not going to be talking about cognitive services, although I will mention that Microsoft added to the Spark implementation to create an MML version that does make it easier to call cognitive services from within Spark, which is really pretty cool. All right, so Spark's clusters are also used in Databricks, but so that's how some people have been habituated to them. Apache Spark pools are, of course, the open source Hadoop in-process memory processing, and they're designed to use data from Azure Data Lake Gen 2. You don't have to, but that is the easiest way to get into that. It processes different data files. Spark is optimized to use Parquet, so you are better off if your data is in that format. If it's not in that format, it's relatively easy to write a simple Python job to convert it to Parquet, or you can even do something super simple and integrate to convert your data to Parquet. So that shouldn't be a really big barrier and will perform a lot better if you have it in that format. So it's also preloaded with Anaconda so that you have all that functionality included within it. Of course, you have the ability to incorporate all of your libraries as well. This was a full feature, but that is something that has changed. Along with the number of changes that were added, Spark is now running 3.0. As kind of a trial, but it still counts within Synapse. So you have the increased functionality that all of that brings, including the ability to do full-on ANSI SQL now when you're writing SQL within Spark. Before it was like close to ANSI SQL, but now it is ANSI SQL. So having that is a really great feature that I was really glad that Microsoft included. All right, so Apache Spark, what do you get with that? You get open source parallel data processing for big data analytics. You can use batch processing, interactive, real-time, and looking at what we're going to be looking at, machine learning, deep learning, and graph processing. So Apache Spark, for those of you who don't know, was originally created so that a bunch of graduate students at Berkeley could try to win a contest at Netflix to see how to pick the best movies. They lost, but we got Spark out of it, so it's kind of a nice consolation prize for the rest of us. So machine learning in Synapse, I will say that it is very similar to Databricks, but of course it's not the same. You are charged when your cluster is in use, and unlike dedicated pools, it will stop on you. I found out it also stops on you when your portal goes down, which is somewhat interesting. You write your code in notebooks. Those notebooks within Synapse are Interact notebooks. Interact was originally designed to be an easier notebook to load on machines. It's kind of nice. It has some WYSIWYG features so that you don't have to be a markdown guru to get it to go well. And you can write code in Python, C#, Scala, and of course Spark SQL. You will notice that R is not on that list. That's one of the differences between Synapse and Databricks, and frankly, if it was there's with the decreasing number of people who write R, I'm not so surprised that it's not there. So, all right, so what can you do in a Spark pool? To be honest, not to throw any shade on people who are doing a lot with integration or ADF, but a lot of people are starting to write ETL in Spark pools. They find it to be a more cost-performant way of doing it. So what I'm seeing is more and more is people moving to Spark, not only to do ML, but to do ETL. And that allows them a nice way of doing that, because you can also use these Spark pipelines for that. It's the version 3.0 that was in May 23rd, and now if you've got that, you've got ANSI SQL. So Spark uses open source Apache Hadoop. It's got resilient distributed data sets. Generally speaking, for these, you're going to want to use data frames. If you don't use data frames, you are going to want to use the Spark structure called koalas. The reason being is that the koalas and as well as the data frames will allow your data to be distributed across the scalable nodes that exist in Spark. If you are using pandas, you may have issues with scaling because it doesn't know how to spread the load along the different clusters, so you may run out of memory when using pandas. So you'll want to be using Spark data frames or koalas primarily within Spark. Now I know that there's an issue with doing visualizations with koalas. It's something that the team at Databricks has incorporated. It was announced in the Data AI Summit that there is now some graphical capability with koalas, which makes using it easier. And the other thing with that Spark uses is it uses the MLlib library for machine learning components, and also incorporates Azure ML, which we are going to be taking a look at. So what is inside of MLlib? So there's a number of different algorithms that you can use to code Spark. It includes all the common ones for doing classification, regression, and clustering, and collaborative filtering, and you can even do deep learning with it. The featurization provides libraries to assist in the way you're modeling the data so that it can be structured in a way that your models can best use it. It allows you to things to do like one-hot encoding, and that is going to allow you to format your data sets so that it can be more readily available in a format that your machine learning components are looking for. The other thing is you've got utilities to help you create statistics, to use linear algebra to more analyze your data, and of course you've got pipelines. So you have the ability to create transformers to produce predictions and estimators to produce these models. And those are combined within your pipelines. So you can predict labels with feature vectors and calling a fix. They'll train the data into a model, and then that'll make it a transformer. So these elements, and then you can take the transformer and generate a model that you can persist out of that. So that's a great way of encapsulating different functionality that outside of Spark you may be doing a little bit differently. You're going to want to look at using the pipeline functionality to improve the overall performance. So this sample code implements the building blocks that I was talking to on the previous slide. So here we're looking at creating a pipeline. And here, if we look at that, we look at a tokenizer, hashing, and my logistic regression. So these are just my how I would write the code to do this within Spark. So I've basically taking some words, looking for features within my words, doing logistic regression to see if I can find different elements in the words, how good I am at guessing that. I'm creating my pipeline with my tokenizer, my hashing, and my logistic regression, and then train my pipeline and test my pipeline. Pretty simple functionality to do that within Spark. So you can also tune your pipeline, and MLlib will help you out by selecting the best hyperparameters that you could possibly use within your model. And you can use the individual algorithms and estimator or for the whole pipeline. And the data is evaluated and help you get the best results in your hyperparameters, so you don't have to worry as much about hyperparameter tuning. So here, this pipeline is treated as an estimator, and this allows me to jointly choose parameters for all the different pipeline stages. So let's take a look at code that implements this. Going to go ahead and open that up. So within Spark, obviously, I've got a number of different notebooks here. Looking for my MLlib pipeline. So this is an illustration of the code that I just did on the previous example, just showing you how I could actually implement that pipeline here in code. With my using just straight up Spark to import my pipeline, importing logistic regression for classification, and doing a hashing and tokenizer. So I've just got a simple data set here just for purposes of making it really easy to do predictions. So what I'm looking for is I want to look for the ability of my algorithm to find which strings include the word text. So I could use this for finding different elements of data if something was a lot larger, but I just wanted to show you how that would work in this particular environment. So I'm going to this is my data set, and I'm going to do predictions to determine which arrays have the word Spark in them. So I'm going to be looking for my text words. I'm going to be doing logistic regression, and then I'm going to fit it and then run to determine which one's the best answer, and then test it. So I'm going to go ahead with all of that and run all of this. Just a little bit about us. Why is it not? Fudge. I need to go ahead and stop my existing pool and then get it to start again, because I have over allocated cores. For those of us who are not working at Microsoft, we have limited amounts of elements that we can possibly include, and I was running something earlier, and now it's still running. It is not behaving, but what it was running, I want to make sure that this is what I was running that didn't help me any, because it crashed. All right, so let me go ahead and manage my Spark items so that I've got enough resources to actually run those. So what this is cancel. Because my issue is that I've got to stop this. And I want it to just stop. Oh, really? Support can up that for me? That will be awesome. I will definitely tell them to do that. I didn't realize they would do this, because this is a lowly free account, so I didn't know how much pull that I had with them to get them to give me more stuff. Yeah, stopping is kind of a pain. I wish I could stop it more easily. Put that in my hint items there. All right, so hopefully, since I've got it stopped, it says it succeeded. I also successfully applied my scaled this to start with 5 nodes so that it will run more efficiently. Because like you and I originally had this at 3 nodes, because I also am cheap, and I also run out of nodes, as you can see. So it is telling me that I do not have enough capacity. Well, I'm going to scale my, see if I'm running anything. All right. I should not have scaled my pool because it's not taking my new settings. So I'll just have to go down to a lowly 3 number of nodes. And for sure that will work. So this is, all right. So hopefully now that I've scaled it down, I'll have the acceptable number of cores in my lowly Azure account so that I can run this session. So what I'm doing basically is, you know, a little time to course to return after I stop. Yep. Sorry that this is going to, it applied it. Great. Now that means it'll start it now. So what this is going to do, once I've got my model fit, then I'm going to, you know, test it, and then I can predict how well it is going to find the word Spark using logistic regression based on my training set. So I've got a test set, I've got a training set, and then I'm going to be able to make predictions based on that. So the difference in doing this and other methods you might have done if you're not using Spark pipelines is this step here where you're configuring the pipeline, and then you're fitting your pipeline to your training documents, and then testing it, and then getting a prediction. So with that is going to start it up eventually. Thank you. Yes, it would be nice if it stopped earlier. I would like to try to make sure that I can start things in advance, and sometimes that bites me because then I'm run out of space. So it will be nice if this started a little bit faster. Spark can take up to 4 minutes to start a session. So let me, while this is running, show you another illustration of doing another type of machine learning task within Spark. So here, what I'm doing is I'm also going to create an ML pipeline while my other one is running, because this one didn't run. And what I'm going to do on this particular classification algorithm is take a look at data from within my data lake and analyze my data to determine whether or not a given customer is likely to purchase a new product, given what we know about them and given our marketing campaign and their how they reacted to the previous marketing campaigns. And so I'm doing that with raw data that I have here, and I am creating a path for my raw data. I'm getting it from ADLS Gen 2. And then I am grouping by my different clients, displaying it, doing some pre-processing of my data. I know, as an example, I talked about the ability to do one hot encoder, which I'm going to do here because I have different job class, people who have different jobs. And instead of all of that being in one column, I'm going to blow that out so that there's multiple columns here. So while this is going on, let me take a look at seeing if this is complete. So what it's doing here is, yes, it's completed. So I've loaded my libraries. I have my little training data set here. I am configuring my ML pipeline using logistic regression. I'm fitting my pipeline to my little training set here, which is here. And then I'm going to create some new test data so that it doesn't have the answers. So here, as you can see, if it says Spark, I have an answer saying, yes, it's true. Yes, it's true. No, it's not true. And so for my test data, I notice I've taken that off, so it has to determine whether or not my text says Spark in it. So I'm going to ask it to predict it and then evaluate my model performance. And as you can see, it's very good at predicting the fact that that it says that I have the word Spark is included here, which is why I have a prediction of 1. No Spark here, so the prediction is 0. And the fact that I have Spark in here twice, interestingly enough, for the first word, it didn't do the guess very well, but it did a lot better guessing on the second word. So interesting prediction there, but overall prediction was correct. So looking at my words here, it did a very good prediction of determining that no, none of these have the words Spark in them. So that's my little test model, which allows me to show how to do a machine learning pipeline within Spark. Now I wanted to do my classification algorithm to give you an idea of what a more complex pipeline looks like. Let me make sure that I've got I'm going to go ahead and stop this so that I will be able to run this and not run out of resources. So I'll go back to describing what this particular one does so that it can get to done stopping, and then I'll go ahead and start it and run this. So in my data here, what I'm going to do is I'm going to create these categorical columns. I've got my data indexers determining these are different classifications of information about my customers. And then I'm going to identify, how these different features look, and then create split data sets and training data sets using 80-20 rule here. And then I'm going to create some different, create my pipeline again, and then do some predictions based on my data. So let's see if that got stopped. Nope, not stopped yet. What I'm doing here, though, is I'm also doing a number of different types of model tuning here. Also tuning my hyperparameters, letting it pick my hyperparameters for me, which will, of course, improve the performance of my predictor model here. And then creating a model based on that. So with this model, though, what I'm doing, though, is I am guessing which is the appropriate algorithm that would work best here. I'm not sure. I think that it would work, that I've picked the right algorithm, but really to test this, I would need to ensure that I run a number of different tests and I use a number of different algorithms to make sure that I have indeed picked the best one. Well, that can take quite a bit of time, and I have to go in through my code and modify it. And see if this is stopped. Well, not yet. We'll sit and see it run it. It'll start it when it can. And I would have to, perform this particular process a number of times to make sure that I have the right algorithm. Well, let's say that I'm in a hurry and I've got other things that I want to do. I want to take a look at a way of how I can have machine learning determine which is the best algorithm in a given situation, so that I don't have to spend all of my time running different algorithms to pick the right one once I've got all of my data configured. Let's take a look at another way of doing that. So to do that, while this runs, oh good, it's getting my data. So because you can see here, I'm just using the one algorithm, and then I'm tuning it. So what's another way that I can do this? So we'll let this run, and we'll talk about another way of doing this, and we'll come back and look at this completed machine learning module. All right. So with these pools, you've got these controls, but what I wanted to look at now is taking a look at what you can do within Azure Synapse and its integration with Azure ML. So with my integration with Azure ML, I have the ability to integrate those elements within, and whether or not this is my algorithm, that this is the experiment that is running, showing out whether or not someone's going to open a CD, doing simple binary classification. And what if I want to evaluate 3 different algorithms? How could I do that? Well, one thing that I could do is I could take a look at AutoML integration in Azure Synapse. AutoML is a library that is included as part of Azure Machine Learning that I can incorporate within Synapse and use that functionality as well. So combining using libraries, the capability of using multiple projects within Azure, and allow me to have the machine pick an algorithm for me, saving me some time that I might be able to do some other tasks. So it's going to select the algorithm for me based on what criteria that I've told it that I wanted to. So let's take a look at that now that my job is probably done running here. So what I've got here is I've got my weather, I've got my data here, and I'm looking to see, start at the top, loaded all my libraries, loaded my data, and this is what my data looks like, all the information that I have about my customers. So I've got age, job, marital status, housing loan contact, and I'm going to be showing this is what the data looks like. And if whether or not they have responded to my previous promotion and gotten a CD, I'm looking at my split here, and I've got a yes/no split for people who responded last time, which I can make prettier if I show this in display. And what I want to do is I want to take a look at my jobs that I've got here. And what I'm going to do with all of these jobs is, instead of looking at them like this, I'm going to change my data. That's where I'm using this one-hot encoder to split them out into columns so that they are going to be looking at the whether or not they have that job in a column. I'm also going to put all of my features into an array and then categorize them, which is what this is showing. This is whether or not their job status, etc. So I've reformatted all of my data so that it works well within machine learning. So then I can do my evaluation here and start doing predictions of my data and see how good I am for predicting whether or not someone is likely to respond to my advertising and get a new CD product. So I've got my predictions here, taking a look at that, and my accuracy is 80%. So not bad. This is test data. Real world is worse, is different than that, but that's going to be kind of hard to, but you know, there's quite a bit of work in just changing this up to use different machine learning algorithms to test if that's the best that I can possibly do. So let's take a look at what we could do with machine learning and how we can incorporate different libraries to be able to do prediction for us. So what this is actually utilizing is it's using my instance of Azure Machine Learning. And with this Azure Machine Learning, it contains a AutoML functionality as well, so that you can do an automated version of it. But it uses these particular libraries and functionalities from within Synapse. And it does that by using the Azure ML library. So let's take a look at that. So I'm loading in a bunch of data here. I apologize that I can't show you this running. It crashed, and it does take a couple hours to run because I have quite a bit of data here. And so what I'm doing here is I am creating a data frame with my tip information, featureizing it, and then I'm creating some different evaluations on it. And that's the wrong one. Where have I got AutoML? Sorry about that. So what I'm doing with this one is here I'm importing my ML workspace. And when I do that, what it is doing, it is taking advantage of my AutoML capability that I have and using those resources as well. So I do have to have a machine learning instance created to be able to run this code where I'm importing the workspace. And it is going to allow me to create a data set that it is going to use And what it's going to use is going to be an auto ML setting. And I'm going to have a lot of different criteria that I'm going to use here, including how long I'm going to run, whether or not I'm going to stop when I achieve the answer that I'm looking for, and how long I'm going to take to time out, how many concurrent iterations I'm going to use, my primary metrics, and cross-validation. So I'm going to be using these settings within AutoML, and I'm going to have it determine whether or not somebody is going to be doing tips or not within AutoML. So I'm taking a specific fair and saying what's the likelihood that person is of getting a tip in New York for a given sets of days. So what I'm going to do is I'm going to configure my AutoML. I want to do some kind of regression. With the AutoML functionality, you are limited in the types of analysis you can do. You can do classification and regression, and time series are the ones that are available at this point. So what this does when I'm configuring it using my data that I have prepped within Synapse is that it is going to go out to my Azure ML instance and use the functionality there and come back and show me which is the best model based on all of the analysis that it has done and the criteria that I provided for it. So what I told it that I wanted to get, that the highest one that I wanted is I wanted my R2 score. And my R2 score would be showing the best score that they could possibly have for this particular, for this particular algorithm. So determining whether or not which one has the highest R2 score, and it's going to come back and run this for me. So, and then it's going to plot my different data elements. So what that does is it goes out here, goes to my runs, and takes a look at the models that I wanted, takes a look at any kind of guardrails that I have, so whether or not there's missing features. And it's going to evaluate as many models as it possibly can do within the time frame and that I've provided. So what it's done is it's gone through 20 different algorithms here, and it's sorted it based on the R2 score because I told it that that is the most important criteria that I have. I want to have the very algorithm that has the best score. And so the one with the best score is voting ensemble. Now notice that these algorithms are here twice. And the reason that they are is because that it's used different hyperparameter tuning algorithms and they have different results. You can also look at how long it took to run different algorithms. So you see here, voting ensemble, that was like 1 minute and 24 seconds. Standard scalar wrapper, that only took 27 seconds. So it allows you to, it's quite a bit of different variability with the different algorithms and how long they take, and also in their scores. So what this is doing for me is it's going through, trying all of these different ways, playing around with the hyperparameters, and then telling me, hey, yeah, you don't want to use gradient boosting, that's terrible. Which one is the best? And all I have to do is pick that one and use it for my model. Now, this is generally a good starter. I will say for doing data science, you rarely can get away with just running this instance and being able to just go from there. But it's a great place to start off with determining where you want to start with your machine learning algorithms by picking the one that's best and having it do it for you so you can do other tasks. Because let's face it, there's always more that somebody is asking you to do than you've got time to do. So it's incorporating that here within Synapse and coming back and providing me the answers to my Azure ML components. And this in Azure ML, it's also using Spark pools as well. So it didn't used to, but it does now. So I am still using Spark pools when I'm doing my compute. So for my what's the cost question it's similar to what you would find within a standard Spark pool. All right. So summary, we talked a little bit about the architecture. We talked about how you develop Spark in ML, and looking at the specifics about the Spark MLlib library, which is what you're really going to want to take a look at when you're playing around with Spark. And then we took a look at AutoML, seeing how it can be used to inside of Synapse to help you do some tasks for picking algorithms for you, so that you can focus on other things and then start expanding upon your algorithms or your process from there. All right, with that, are there any questions that you've got there?